Yep. Does it come up your end as showing it's recording? Yeah, so right. So, yeah, so I started recording this session now. The purpose of these sessions is just give you a little bit of extra. We're aware that it's quite an accelerated delivery of this unit, so we thought we'd give you a bit of something extra. So what I thought I planned for this is kind of like a Q&A. So any questions you have regarding what we've done over the last couple of weeks and also the coursework, essentially throw questions my way and I'll see if I can answer them. Okay, so does anybody have any questions? If not, I can just talk about or go through what I do have something planned. Okay, so whilst you're waiting to ask questions, what I'm going to do is I'm going to share my screen, and then hope so if I just share my screen. It's warts and all, so this is my whole entire screen. Okay, are you able to see the this? Are you able to see my screen and a web page? I just need to bring up so I can still access the chat. Okay, so you can see what I see now. Yeah, thanks, Georgia. Right, so still getting used to this, so bear with me, or bear with bear with us all. Where's that chat gone? There we are. Excellent. Okay, so if I just go back to the ODE's Moodle area. Okay, so what I want to show you is in week 3. Okay, so later on in the tomorrow and Friday we'll be looking. You can see, but we'll be looking at stability and boundary value problems. Now I'm just going to go to the assessment for this unit. Okay, so here's a coursework assessment split into 2 parts. So my questions are 3 and 4. Okay. So I mentioned in part 3A now from your emails that started to attempt this. I did have a couple of emails regarding are these the correct values? Yes, they are. Okay, so with the examples in the notes, because these are different values for the coefficients, you may have to change the order conditions which you are using to derive the run-cutter method. So it's not as straightforward as just plugging these in to the example and running it. There may be a different number of order conditions. And part 3A2, determine the stability function. So that's what I mentioned we're going to be looking at later this week about the stability. A question from Sophie. Yes, I will be uploading video lectures. Okay, I have got to record them, so apologies they're not ready for you prior to today actually. But yes, I will be uploading video lectures. Okay. So that was the stability function. Right, so if I go back to week 3, okay, so we'll be doing stability later on this week. If I look at week 3, okay, what I've actually put up is the solutions to week 2 exercises. So this will help you with the coursework as well. So there are solutions, and if I click on week 2, go up here, click on week 2. Okay, there are solutions. So I release the solutions as MATLAB live scripts. So for example, if I click on run-cutter methods one, so these are the same MATLAB live scripts as we've been using in the webinar, but with all of the examples filled in, completed. So you can see in the webinar I went through and completed these examples, so these are all complete. Okay, so if you scroll down, you can see here we've got the solutions to the exercises and where they require MATLAB. Okay, you can see I've got a solution here. So one which may be useful for you in the assignment is we have this solution here. Okay, so this was deriving a 4th order run-cutter method given a couple of values of the coefficients. Okay, so we're just given just 2 here. Well, in the coursework, okay, I've given you 4. Okay, so that means it will change the number of order conditions that you require. Okay, so you can base, make use of this, but you will have to change it. It's not as straightforward as just changing these values here. Okay. Right, so what I thought I'd do, unless you have any other specific questions or elements that you would like me to cover, I thought if we go to the notes, okay, so at the end of the implicit Runge-Kutta method chapter, okay, I've got some of these, so I thought I'd talk you through some of these questions. Okay, so the first one, show that the Radel 1A method derived in example 3.3 is a third order method. Okay, so here's the method. So end up with this butcher tableau, and I'm going to show you that's a third order method. Now I'm going to do something which is a bit experimental. I've recently got a new toy of a document camera, so we're going to see how this goes. Okay, so bear with me. I'm just going to write down what that butcher tableau is, and then I'll switch to the document camera. Okay, so what I'm going to do now is just experiment. Hopefully you can see, can you see a butcher tableau? Are you able to see what I'm seeing, which is a butcher tableau? No, but you're sharing the screen, because you're, I'm still sharing my screen. Like I say, this is all very experimental. So now it's good. So you can see, is this, again, I'm using you as a guinea pigs, guys. So is this in mirror? Is this mirrored at all? Or is this, like, looks good, looks the right way around? No, it's not mirrored. Oh, that's good. I'm seeing it and it's mirrored. So this is really bizarre, but we'll crack on. Okay, so we have this implicit Runge-Kutta method. It's got 2 stages. We're going to determine what the order is of this method. Okay, so I'm just going to remind ourselves. So we have to check the BK order condition. And the BK order condition was the sum I equals 1 to S, BI, CI to the power J minus 1 is equal to 1 over J. And that was for J equals 1 up to K. Yeah, so is that, can you see that okay? Yep, all good. Thank you. Thanks for feedback. It's really valuable. So we have 2 stages. So we first check when J for the BK. We check when J is 1. So we're going to sum. So because J is 1, the power of CI will be 0. So CI is just going to be 1. So we just got the B1 plus B2 is equal to 1. Okay, so that's left-hand side. So that'll be B1, B1, got that wrong already. So B1 is a quarter, B2 is 3/4, so that equals 1. And the right-hand side, just very simply 1 over 1 is 1. So that's correct. Okay. Check for J is equal to 2. So this time we do have the power of CI will be 1. So we have B1 C1 plus B2 C2. So we've got a quarter, which is B1 times 0, plus 3/4 times 2/3. And I'm starting to get the sense I've done this one before. Have I been through this one before with you? Seems very familiar. I have. Oops, sorry about that. Okay, right, so I was just doing that then, and I thought, hang on, this is really, really familiar. So what I'll do, instead of that question, I'm going to move on to one of the other questions. So rather than going back, can you do question 2? Ah, yeah, that'll be a good one. 3-stage one. Ah, you're making me work. Okay. So question 2, I'm just going to write down what the butcher tableau is. 0, 1 half, 1, 0, 0, 0, quarter, quarter, 0, 0, 1, 0. So this one's going to be quite involved because it's got 3 stages, and I'll show you why in a minute. 1/6, 2/3, and 1/6. Okay, can you see that? Okay, so I can't actually see. It's out of frame. Sorry about that. Ah, yeah. Okay, so this is 3 stages. So for the B condition, so when J is 1, we have the left-hand side, which is B1 plus B2 plus B3, which as you can see is all zeros. So that's going to be 0. Right-hand side, oh, sorry. Oh, dear. So that's 1/6 plus 2/3 plus 1/6. That obviously is equal 1. Hopefully that's not too small on what you can see. And the right-hand side will be 1/1, which is 1. So left-hand side equals right-hand side. When J is 2, got the left-hand side is B1 C1 plus B2 C2 plus B3 C3. Okay, so we've got 1/6 times 0. It's going to be 0. 2/3 times a half. It's going to be 1/3. And 1/6 times 1. So what we've got here, we've got 1/3 plus a 6, so that's 2/6, so that's 3/6, that's going to be 1/2. And right-hand side is 1/2 as well. So that's so you can see those are satisfied. Okay, so all we do as we go down the B condition, we just add in 1 to the power of C. Okay, so this is going to be 0, so no point putting that there. So we're going to have 2/3 times a quarter. So 2/3 times a quarter, that'll be 2/12, so that's 1/6, plus 1/6. So that equals 1/3. And the right-hand side also equals 1/3. Okay, so we're satisfied up to J equals 3, so we keep going until we no longer have left-hand side equals right-hand side. I don't know how long that's for. It's been a while since I've done this one. So we've still got 0. So here we've got 2/3 plus 1/8. So that'll be 2/24, which is 1/12, plus 1/6. So that'll be 3/12, so it'll be 1/4. And the right-hand side is 1/4. Okay, so keep going until left-hand side does not equal right-hand side. So it's going to be 0 still. So now we'll have 2/3 times to power 4, 1/16. So that'll be 2/30. Right, I'm reaching for a calculator at this point. But remember that. So I'm just going to reach for a calculator. Give me a sec. Just doing off camera. My mental arithmetic is not good enough to do all that, and I'm waiting for my computer to respond. It's not responding. Oh, right. So where was I? Sorry. It's 1/16 times 2/3. Anybody? 1/24. Thank you. And yeah. So what we have here, so 1 over 24, so that's 4 over 24, so that's 5 over 24. Looks like this one's broken it, because that's not equal to 1/5. That's a relief, because I didn't want to go for much further than that. Sorry, is that out of shot? Okay, so you can see there we have left-hand side no longer equals right-hand side. So j equals 4. So this is a maximum of 4th order. Okay, so that's going to have a maximum order of 4. So if you halve 4 and then round it down, okay, so we get 2. And if I bring in the order conditions now, okay, this is slightly different from the previous examples. Now what we do is got L is going to go 1 to 2, and I is going to go 1 to 3. Okay, so we're going to have 6 order conditions to check for C. So quite a bit of work for this one. Okay, so we're going to check the C half K condition. So start with when L is 1, okay, and when I is also 1. But the left-hand side is going to be A11, that's the row sum condition, A12 plus A13. So I know you can't see that, but you can see the row sum conditions, that's all the zeros, that's going to be equal to 0. The right-hand side is, so the right-hand side of the C condition is 1 over L, so it's going to be 1 over 1 times C1 to the power 1. Okay, that's also going to be 0, so left-hand side equals right-hand side. So when I is equal to 2, again, the row sum conditions, so the second row of A is 1/4 plus 1/4 plus 0, so that's equal to half. Right-hand side is 1 over L C2 to the power 1, so the right-hand side is a half as well, so that's right. And when I is equal to 3, left-hand side, third row, 3, 2, 3, 3, so 0 plus 1 plus 0 equals 1, and the right-hand side, again, 1 over L C3 to the power 1 is 1. Okay, so this I've checked. So this is the C condition for when L is 1. We also have to do the same for when L is equal to 2. Okay, so this is going to be the C condition. This time L is equal to 2. Okay, so for I is equal to 1, we've got left-hand side. So this time we're introducing the C values. So that's going to be A11 C1 plus A12 C2 plus A13 C3. Okay, okay. So Twitchy Tableau. But okay, stop here. I understand it now. One thing I want is that everyone else. I mean, I would rather continue on to do the whole thing, unless anybody wants me to stop. Yes. Okay. I'll continue to do the whole thing. Yeah. Okay. So A11 is 0. So this is all going to be zeros. Yeah, I know it is long-winded, but it's you know, it's one of those things we have to check. Okay, so the right-hand side is this time L is 1. Sorry, L is 2. So I've got 1 over 2 C1 to the power 2. Okay, well that's just going to be 1/2 times 0 squared equals 0. So left-hand side equals right-hand side. Okay, when I is equal to 1. Again, I try and speed this up somewhat. So we've got A21 C1 plus A22 C2 plus A23 C3. Okay, so that's going to be 1/4 times C1, which is 0. That's 1/4 times C2, which is 1/2. oops, plus, we've got A23 is 0 multiplied by C3, which is 1. So that's just 0. Okay, so that's equal to 1/8. Don't know if you can see that there. Right hand side is 1 over L C2 squared. That's C2 squared was a half, so that's a half squared. So that's going to be 1/8, and that's left hand side equals right hand side. I equals 3. Again, same thing again. I know it's long winded, but it's nobody said it was going to be quick. So I've got 0. First one's 0, so I'm not going to bother with the next one. That's 1 times C2, which is going to be 1/2, plus 0 again. So that's going to be 1/2. And just double checking that. Yeah. Right hand side is going to be 1 over 2 times C3 squared. So C3 is 1 squared, so that's a half. Okay, so what that shows is the C2 condition is satisfied. So you can see when we go up in the order, we got L is 1 and we also got L is 2. So now we're going to have to check for the D2 condition. So we've also, and again, the D2 condition also has L is 1 and L is 2. Okay, so D2 condition is here. So L is 1 and 2, but this time J goes from 1 to S. So again, L is 1. So when L is 1 and J is 1, just try and shuffle that up so you can see it. Oh, sorry. Like I say, it's all mirrored for me. So we have the left-hand side. Well, this time I'm just going to have B1 multiplied by A11 plus B2 multiplied by A21 plus B3 multiplied by A31. Now this is just from the D condition. So right, so we have B1, which so we have B1, which is a 6th times 0. B2, which is 2/3 times 1/4, and B3 is 0 times 1/6. Okay, so that's going to be equal to 2 over 12, so that's 1/6. Right hand side, we have slightly trickier, so we have B1, 1 minus C1. Okay, so B1 was the 6th, 1 minus C1, which is 0, so 1/6. Okay, and we keep going. So this one we've got B1. So this is the same one, but with the second column of A. A2, 3. No, sorry, A3, 2. Okay, so we're going to have 0 for the first one because A2, 1, 2 is 0. We're going to have 2/3 times 1/4. And we're going to have 1/6 times 1. So what we've got here, we've got 2 over 12, which is a 6, plus a 6, which is 1/3. Okay, right hand side will be B2, 1 minus C2. So B2 is 2/3, 1 minus 1/2 gives me 1/3. Right, J is equal to 3. So we have again the third column, B1 A13 plus B2 A23 plus B3 A33. So all the way down, if I show you, all of these are going to be 0. So that's going to be 0. And the right hand side going to be B3 minus 1 minus C3. So that's going to be 1/6 times 1 minus 1, 0. Okay, so the D condition is satisfied when L is equal to 1. Can you see that? Sorry, yeah. Equal to 2. Okay, this is slightly more complicated now. We've got J is equal to 1. So the left-hand side now becomes, because our power of C is 1, so we've got B1, C1, A11 plus B2, C2, A21 plus B3, C3, A31. Okay, so based on B1 was 1/6. Somebody got can hear a bit of sound. If you mute your microphone, unless you want to ask a question. So C1 is 0, A11 is 0, plus B2 is 2/3, and C2 is 1/2, and A21 is 1/4. And we have 1/6 plus C3 is 1 multiplied by A31, which is 0. So that's going to be 0. That's 0. So we have 1/8 times 2/3. So that's 2/24, 1/12. Okay, and right hand side. And this one's slightly trickier. So we have 1/2, 1/L. Oh, I've got the B1. Should have had B1 there. 1 minus C1 squared. So it's 1/2 times B1, which is 1/6, times 1 minus 0. So that's 1/12. Okay. Where are the time? It's almost time. Would you like me to carry on? It will take about 3 more minutes just to finish this. Okay, so I'll just carry on. The left-hand side is B2 this time. So instead of B1, C1, A11, I've got B2, C2, A21. Oh, sorry. B1, C1, A12. Sorry about that. It's the J. Sorry, it's the. Just make sure I'm getting this right. So J is 2. Yeah, so it's a J which has changed. Sorry about that. So then B2, C2, A22 plus B2, C2. Sorry, B3, C3, A32. Okay, so plug in the values. 1/6. C1 is 0, so that's just going to be 0. A12 is going to be 0. B2 is 2/3. C2 is 1/2. 1/4. B3 is 1/6, but C3 is 1, and A32 is 1. So that's just going to be 0. What have we got here? We've got 1/8, 2/24, so that's 1/12, plus a 6. So that's going to be 3/12, which is 1/4. And the right-hand side. Oh, sorry, could you not see that? I don't know whether. Okay, and the right-hand side, we'll have 1/2 B2 1 minus C2 squared. Okay, so we've got 1/2 times B2, which is 2/3, times 1 minus C2 squared. So it's 1 minus 1/2 squared, which is obviously 1/4. So it's going to be 3/4 times 2/3. So that's going to be 6/12, which is 1/2 plus 1/2. Hang on, I'm just going to double check that. So 1/2 of 2/3 is 1/3. Oh yeah, it's 1/4. a third of 3/4, 1/4. Okay, and last one, so bear with me. Just for the last one, we have left-hand side, B1, C1, A13, plus B2, C2, A23, plus B3, C3, A33. So that's going to be 1/6, 0, 0, plus 2/3, 1/2, 2, 3, 0. Oh, these are all going to be zeros, aren't they? That's 1/6. That's 1, 0. So that makes it easy. And hopefully the last one's easy as well. So we've got 1/2 B3, 1 minus C3 squared. Okay, so 1/2 times B3. So it's 1/6. Oh, sorry. 1/2 times 1/6 times 1 minus 1. Whew. Right, so we have left-hand side equals right-hand side. So if we, that was our 3 pages of working. So we have B4 is satisfied. Can you see that yet? And we have C2 is satisfied, and we have D2 is satisfied. So this means this is a 4th order method. Whew. So after all of that, 3 pages of working, we know we checked the B2, we checked the half before to give us 2, and we checked the C and D conditions, and we can see that's 4th order. Right. So yeah, I'm gonna have to double check that. I don't. Anybody spot any errors in what I've just done? So Sophie mentioned it, but said 3rd order. Okay, so thanks, Sophie. Yeah, so Fozia, you said what would happen if D2 wasn't satisfied? That's a brilliant question. The highest order, let's say C1 was, let's say it was satisfied to C1, and doesn't matter what D, let's say it was satisfied to C1 and D2, this would mean it would be a maximum order of 2. Okay, so what you're looking for is the maximum value of K. So this is K, that's K over 2, and that's K over 2. You're looking for the maximum order of K for which these 3 are satisfied. So if this was satisfied to 1, it doesn't, and this was satisfied to 2, say, that would be this will be a 2nd order method. So it has to be all 3. Okay, likewise, if D1, let's say D was satisfied to 1 and C was satisfied to 2, B could be satisfied up to 10, but it will still only be a 2nd order method. If C or D aren't satisfied for 1, you haven't got a Runge-Kutta method. It's just some numbers. Okay, it doesn't satisfy the minimum criteria for a Runge-Kutta method. I'll double check that solution in the notes. Okay. Yeah. We can actually do all of this calculation a lot quicker on MATLAB, but it is a bit picky. Okay, right. Thanks, guys. Okay, so as you've seen from the announcement on Moodle, we'll be doing some more of these. What I'll plan to do is either go through maybe an extra example or some of the solutions to the exercises. If you've got any questions and you want me to specifically look at, by all means, shout out next time. Okay, so that was recorded. So if you really want to watch all of that again, you got the benefit of fast forwarding it on the recording, but I'll put that up on Moodle as well. Question, are the solutions up for chapter 3? Let's have a look. I may have put them up, but I may have hidden them from you. So I want you to do them yet. Chapter 3, yes, if you go to week 3, I think they're there. They're up but empty. I might have uploaded the wrong one. No. Yes, so what I see what you mean by that. Okay, so I think I've uploaded the one with the examples filled in, but not the solutions. Okay, I look when I get a chance. I look about correcting that. Okay then. Thanks, guys. See you next time.